Now, in this problem, which is problem 15-59, you have a particle which is this ball A having a mass of 2 kg, and it is thrown towards this block B with a horizontal velocity of 4 meters per second. The coefficient of restitution between these two particles is given to you as 0.8. You need to determine the maximum height h to which this block will swing before it momentarily stops. So इस collision के नतीजे में block B is going to get some momentum. What should be the maximum height attained by this block after this collision? You have to find out that maximum height h. So first of all, is it a case of central impact or oblique impact?
Sir, from the figure it is center.
So from the figure, it is clear that this is a case of central impact. So this is going to be the line of impact, which is the x-axis here, and this is going to be the plane of contact. So आपके पास y-axis आ जाएगी. Although as far as this central impact is concerned, you don't require that plane of contact. उसकी ज़रूरत आपको पड़ेगी once we are discussing the oblique impact problem. So since after joining the mass centers of these two colliding particles, the velocity of particle A before collision is along the line of impact, while particle B was at rest. So this is a case of central impact. So once we have recognized that it is a case of central impact, applying step number 1 on this problem, that is the initial momentum of the system along the line of impact should be equal to the final momentum. So as far as the momentum of this ball is concerned, it is going to be 2 multiplied by 4, where 2 is the mass of this ball and 4 is the velocity of this ball. The momentum of block B, what is the momentum of block B?
Momentum 0.
Since block B was at rest before collision, so it would have 0 momentum, and that should be equal to the final momentum, which is 2 VA2 plus 20 VB2. So you are going to get one equation in terms of VA2 and VB2 in step number 1. Okay, for step number 2, what we are going to do is we are going to apply the coefficient of restitution equation along the line of impact. The value for this coefficient of restitution is already given to us as 0.8, and by formula this coefficient of restitution would be equal to VB2 minus VA2 divided by VA1, which is 4, minus VB1, which is 0. So this will give us the second equation in terms of VA2 and VB2. So once we solve these two equations simultaneously, they will give us the value of VA2 to be equal to minus 2.54 meter per second, whereas the value of VB2 comes out to be 0.655 meters per second. The negative sign of VA2 represents कि collide होने के बाद block A is going to move towards the left, while the positive sign of VB2 represents कि collision के बाद this block B is going to move towards the right with a velocity of 0.655 meters per second. So these are the two steps which you will be requiring for finding the magnitude of these final velocities. Now, once this block B has got this much of momentum due to this velocity 0.655 meters per second, now how you are going to find out the maximum height attained by this block B? What principle should you apply here?
Conservation of energy.
So you are going to apply the conservation of energy principle on block B from position 2, which is just after impact, to position 3, which is the position of maximum swing, जिस पे ये height h आपने find करनी है. So applying the conservation of momentum principle on this block between position 2 and position 3, which says that T2 plus B2 should be equal to T3 plus V3. The velocity, the kinetic energy is given to you as half mv square. So it is going to be half 20 into 0.655 square. Let's suppose that we are defining the datum at position 2. So if the datum is being defined at position 2, what is the gravitational potential at datum?
0.
0. What about T3?
0.
The T3 represents the kinetic energy of this particle at position 3, which is the position of maximum swing. So once the block has attained maximum height, it means that the velocity is going to be 0 at that maximum height. Therefore, T3 should be equal to 0. What about V3? Should it be positive or negative?
Positive, sir, above the datum.
Since position 3 lies above the selected atom, so it should have positive gravitational potential, and the value is going to be W times H. So from this equation, the only unknown quantity is H. So once you solve it, the value of H comes out to be 0.0218 meters. So this is going to be the height attained by this block B as a result of this collision. At position 3, the block would be momentarily at rest and then it is going to swing back again. Any query regarding this central impact problem?